Hey there, grade 6. New video for today. This one focuses on choosing and interpreting graphs. It is the last lesson in our graphing unit. There's only been 6 lessons so far, so after this one and we do the practice in our workbooks, then we're going to get into some practice test stuff and then get ready for an actual test. So by the end of this video, and then hopefully the end of the practice, we will be at the point where we can say, I can investigate which type of graph is more convenient for analyzing data in various ways, which, man living, is not an amazing way of saying like, I can look at a data set and figure out which is the best kind of graph to use. That's really what we're kind of doing. So here's where we're going to start. So it says that Arsham found some data on whale sightings in the Gulf of St. Lawrence in the summer of 2018. And here is our data set. Notice that the number of whales seen on a given day is sort of listed here. So the instruction says to draw a bar graph for the data. So I was thinking about how to do this. There's probably a couple different ways that we can do this. And I think the first way that we can do this is just a bar for each of these days, right? And so I picked a scale of, intervals of 4. So my scale starts at, starts at 0. I should probably pick the right tool here. Starts at 0, and then it goes up by 4s and stops at 60 because that's just past the highest value. And so here's June the 1st, and the number of whales is 27, so that's right here. I'm going to draw a very thin graph, and I'm not going to use a ruler, which I really should be doing. I'm also going to change the line thickness so the bar graphs look a bit better. Close that down. And then that's going to look like a bit more of an accurate graph. Cool. All right, June 8th was 34, which is roughly, let's see, that's 32. It's actually halfway. So here's 34. On the 16th, it was 17, so that's down here. Right, just above that line. Then there's 15 on July the 3rd, which is just below this line here. And then on July the 4th, it was 21, which is just up here. On the 13th, it was, 17. July 13th was 17 again. And so it's, again, just above this line here. So there's, on the 21st, it was 52. Which is like all the way up here. Try and draw a straight line. I'm using my writing tablet. It's a bit hard to draw a straight line on this one. Then on August 1st, it was 31, which is right about here, maybe just below that line. And then on August the 20th, it was 27, which is, right about there. So also understand this is a very messy graph. This is the bar graph for the sightings on each of these days. Okay, that is one of the ways that we could do this and show this data. It makes sense. These pieces are not necessarily connected, although we can make the case that they might be. So we'll go over to this one now. So here's where we are. So now the second graph looks at grouping stuff by month. Okay, and so in June, on those days in June, we noticed that there were 78 whales sighted. So that's, again, it's going to be kind of wonky, but that's that bar. In July, it was 105. So that's all the way up there. Again, as I'm drawing this, I picked a scale of 0, starting at 0, going up by 7s, stopping at 105. I probably could have picked a better scale, like to get a smaller one, but anyway. And then in August, it was 58, which is just above this line. Now, there are advantages and disadvantages for each of these kinds of graphs, right? So we have this one which notices by day, and then this one by month. Okay, so drawing a bar for each day allows you to look at how the data changes over time. And so you might be saying to yourself, well, if we're looking at how something changes over time, maybe a broken line graph is a bit more appropriate, Mr. Versteeg, and you might be right, and we'll get a chance to do that in just a second. Drawing a bar for each month, which is on this graph, might make it appear that whales are more likely to be seen in July than in August, because here's 105 down to 52. However, if we look at this data or our data set, maybe one of the things that we noticed is that there were 4 entries for the month of July and only 2 for August. So if we had 4 sightings in August, it might be that we saw way more than 105. I don't know. You could also draw a bar for a given range of numbers of whales seen. So this could allow you to figure out maybe what days you might see more than 20 whales. So if we go back to our original data set, right, maybe if you want to go on June the 1st or June the 8th or July 4th or July 21st or any of these dates, you could notice that there's more than 20 whales seen. So that could become like a frequency chart kind of thing. What they'd like us to do, and I'll switch back to my very thin line, is draw a broken line graph and then a stem and leaf plot. So I thought I'd do a stem and leaf plot because we haven't really done one for a while. So remember that when we do stem and leaf plots, right, that we split out the ones value from all the rest of the numbers. Now, all of these numbers are just 2 digits. So these are all the numbers that are going to be in the teens or in the tens. These numbers here will be all in the 20s, and then in the 30s, and then in the 50s. There's nothing in the 40s, okay? So if I look at for numbers in the tens, I have 17 and 17. So I've already got my 10 written down, so that means I write 7 and 7. So that's 17 and 17. Cross those off. My next numbers are in the 20s. My lowest one is 21. Then I have 2 27s. Cross those ones off. I missed a number. 15 is one of the numbers that can go there. That gets crossed off. In the 30s, I have a 31 and a 34. And then here I've got 52. I've got all those numbers written down. Now, one of the things that I might notice from writing stuff in a stem and leaf plot is that you could say, well, Mr. Versteeg, you're most likely to see some number between 15 and 30 or 15 and 27 whales. Like that's 6 out of the 9 numbers is somewhere between 15 and 27. So that's also maybe an assumption that we can make or a conclusion that we can draw by looking at this stem and leaf plot. Okay, the last thing over here is they wanted us to put stuff into a broken line graph. And so again, that's going to require us to plot out some points. So again, June the 1st was 27, which is right here. Just draw a dot. June 8th is 34, which is up here. June 16 is 17, which is, right about there. July the 3rd is 15, which is just down here. Then I have to go up to 21, which is right about there. Back down to 17. All the way up to 52. I think I'm off by a date. Let's see. 27, 34, 17, 15, 21, July 13. Yep. So July 20. No, sorry, I was right. Sorry about that, guys. August the 1st, 31, which is just right about here. And then August the 20th is 27, which is right about there. I'm just going to change my color up for a quick sec, change my line style to a dotted line. And then what I can do is actually do my broken line graph. It's kind of helpful with the different color. Sort of see how stuff changes. And so this is my broken line graph, and so we can get a sense of how numbers change. It definitely looks like late July, early August is really the best time to see these whales. And it could be for any number of reasons. Maybe that's when the whales are there to have their calves or whatever else. I don't know. But that's another way that we can see the data in a stem and leaf plot and a broken line graph. So the question that we need to start asking ourselves is that on the bottom here, you might notice that all of our data points are they're not evenly I have them evenly spaced, but I wonder if they should be, because the gaps between these days are not all the same, right? This is a 7-day gap, 8-day gap. This is like 17 days almost, and this is a 1-day gap. So you might want to put the closer dates closer together because maybe this is changing our data a little bit. But you really have to look at your data set, look at the information that's on the axes, and really try to figure out what's the most appropriate way to communicate this information? Is the stuff, is it being arranged properly? Is the range of data numbers along my y-axis okay? There's all these questions about choosing and interpreting this data stuff. And so you really have to read the questions closely. You really have to make a judgment based on the information that you're given, okay? And so that's all I have for this stuff. It is 3 pages of practice. It's 52, 53, and 54. Yeah, I'm happy to go over and answer questions with people, but that's really all I have for this. Is just a few slides. Yep, so 52 to 54, and yeah, best of luck.